So our project is on wind turbines as a control system, and I'm Olivia and I'm working with Lindsey. So for the background, the first wind turbine was made in Scotland by a professor named James Blythe. In 1888, the first wind turbine was made in the US for personal use, and then in 1975, NASA developed the first wind turbine program, which really helped start a lot of more use of wind turbines. So basically, wind turbines are used to generate electricity by the wind, turning the blades around a rotor, which spins a generator, and this whole system is similar to a helicopter and how the blades rotate. And overall, the goal of control for a wind turbine is to obtain as much energy as possible out of the wind by regulating the power and speed, as well as limiting the amount of load that the wind turbine experiences. So for the methodology, different methods are used in order to limit and optimize the amount of power. So there's 3 different ways that a turbine is controlled, and it's blade angle adjustment, generator speed, and rotation of the turbine. So the blade angle adjustment, which is also known as pitch control, is the most effective way to limit power and will change the forces of the blade when there's high wind. And then also you can control the generator speed, which is the best way to get the most power at low wind speeds. And turbine rotation, which is also known as yaw, always make sure that the turbine is facing wind to get the most power out of the turbine. Also, wind direction is unpredictable, so the turbine can get misaligned, and this will cause power output loss.
So the simulation we created used Simulink, and the top simulation shows a feed-forward system that is based on the plant of the disturbance and the plant of the controller. So as you can see, this block here is the feed-forward block, and it will go into the plant, and then that will control the output. And the bottom simulation shows this reduced to 1 block in a perfect case scenario, because these 2 simulations, as we'll see on the next slide, are equal. And because the feed forward block was chosen, as you can see here, to be this block up here divided by this block down here, then that's what makes them equal. The feed forward system, as opposed to a feedback system, takes in the disturbance, and this controller changes based on what it predicts the disturbance to be, and then that will affect the output, as opposed to a feedback system like we had done in class before, where that takes the output and then changes the controller and affects that based on what the output is. Now this is predicting it so it can do it in advance. These are the results from our simulation. The first one is the scope from the first system, which had it in the multiple blocks, and then the second one is the scope from system 2, which had it all reduced to 1 block, as you can see, because it was chosen to be that certain feed forward block that they're equal to each other. And some conclusions from our presentation: the use of feedback and feed forward systems in conjunction with each other allow for the wind turbines to be the most efficient. So the systems that I had done in Simulink was to simulate a feed forward system and also a feedback system. And the way wind turbines actually work, they combine both of them. So they're making predictions based on the measurements of the wind, and then also if the most power and speed are not obtained, then that comes back as feedback, and further adjustments will be made from there. So the feed forward system, like I just mentioned, allows the controller, blade angle adjustment, generator speed, and rotation of the blades to be changed based on a prediction that will be made. And for the future of wind turbines, adaptive elements in estimator and control design are used to improve that preview control. So the best estimates of the wind will result in the best case scenario with the wind turbine. And then the next steps for this include using advanced multivariable controllers instead of single input controllers, and nonlinear transitions between partial and full power production, which will create more advancements for the wind turbines in the future. And these are some of the sources that we used for our presentation and our paper.